All right, we're going to do one more video's worth of story problems. And in this video, we're going to introduce two new vocab ideas. The first of these is angle of elevation. All right, so angle of elevation is just the angle formed by somebody or something looking up. All right, so if you think about sticking your arm or just looking straight ahead, that's the ground level, right? And then are parallel to the ground, and then looking up. So the angle that's created there, that's called the angle of elevation. So our process to solve these problems is the exact same as what we've been doing. Right? We're going to have to start by drawing a picture. So in this one, in this first example, it says the angle of elevation from a kicker's foot to the on the football field to the top of the goalpost is 17 degrees. So let's take a look here at a possible picture. Okay, so we're saying that if this is the kicker's foot here and the top of the goalpost is here, this right here would be the angle of elevation, the angle that's looking up. Then it says the kicker is standing 131 feet from the base of the goalpost. So again, if the kicker's here, and this is the goalpost, this would be the 131 feet. From that, we want to figure out the height of the goalpost. So this would be my variable. That's what I want to find. So then, the process is exactly the same, right? We said first, what we want to do is with respect to this angle, we want to label our sides. So with respect to this angle, my angle of elevation, this x would be the opposite side because it's the side that's not touching this angle, or it's the side that's not a part of this angle. Then this 131 would be the adjacent side, right? Because it's the leg that is part of this angle. Hypotenuse, remember, would be this side opposite the right angle. So now we have to choose which trig function to use. So remember, that's so, ka, toa. So here we're dealing with opposite and adjacent. The trig function that deals with opposite and adjacent is tangent. So my setup here would be tangent of the angle, tangent of 17 degrees, equals opposite over adjacent. So x over 131. Then, to solve this equation for x, all I need to do is multiply both sides by 131. Right? So when I do that, I get that 131 times the tangent of 17 degrees is equal to x, and that I can put into the calculator. Right, so again, remember, make sure that your calculator is in degree mode, and then we'll just say 131 times the tangent of 17 degrees, and that gets me 40.05. So for rounding to the nearest tenth, remember, since the hundredth place is 5 or greater, that means we would round this up. So this would be 40.1. Right, so 40.1, and we were given units of feet, so 40.1 feet is how tall the goalpost was. All right, let's try another example. So in this one, it says a dog is standing 5 feet from the base of a tree, and it is looking up at a cat that's climbed 16 feet up the tree. We want to figure out the angle of elevation this time. Right? So our goal is to find this angle. So the angle is going to be my x this time. The dog is standing 5 feet from the tree. So if the dog's here, the tree's here, standing 5 feet from the base of the tree, and the cat has climbed 16 feet up the tree. So this would be my 16. So from this information, we want to find our angle. Well, again, first thing we want to do is label the sides. So with respect to this angle, this is the opposite side, this is the adjacent, just like in the last problem. So again, we're going to use tangent. So my setup will be tangent of x equals opposite over adjacent. So equals 16 over 5. So now remember, whenever we're solving for an angle, whenever I need to get that variable outside of the trig function, that's when I use inverse trig functions. So I'm going to take the inverse tangent of both sides. That cancels everything out over here except for what's inside, which is just x. So we get the inverse tangent of 16 over 5, and that we can put into the calculator. So remember, the inverse functions are right above the trig functions. So to get inverse tangent, I'm going to hit second tangent, and then 16 over 5. So 72.6 degrees if I round that to the nearest tenth. All right. The other vocab idea for today is angle of depression. All right. This is when somebody is looking down at an object. All right. So if you look at this diagram right here, okay, and let's go ahead and pull up this first problem. This first problem deals with this picture. So it says a lifeguard is sitting on a platform looking down at a swimmer in the water. Okay, so it says the lifeguard's line of sight is 8 feet above the ground. So that means that this height from the ground up to the lifeguard's eyes is 8 feet. The angle of depression is 18 degrees. Okay, so here we're saying, well, if we're looking straight out and then we look down, that angle that's formed is the angle of depression. Okay, so that's 18 degrees. Now, what's really nice about angle of depression, okay, this actually, we're going to use something from the very beginning of the year. Your line of sight is parallel with the ground, right? If you were to look straight out, that's parallel with the ground. Since these two lines are parallel, that means that this angle right here and this angle right here are alternate interior angles. That means that they are congruent. Okay, so I'm going to kind of redraw this down here. So we've got our, let's use the triangle tool. So we've got our lifeguard chair here. We know that's 8 feet above the ground. And we know that this angle of depression that's formed is 18 degrees. But since this is 18 degrees, that means that this angle is 18 degrees. So when we are drawing a triangle, whether we're given the angle of elevation or angle of depression, we can use something like this. Okay, that angle will go here. Right? Whether we're given the angle of elevation or the angle of depression, that's going to go down here in our right triangle. Right? So then, our goal is to find how far away the swimmer is from the lifeguard. Right? So, what we want to find is, here's the swimmer, here's the lifeguard over here, so we want to find this length. All right, now, the way that this question is worded, you might think that we would be looking for this, right? If the lifeguard's here, the swimmer's here, but people can't fly, right? So we're not going to find this distance. We're going to find the distance from the swimmer that the swimmer would have to travel to get to the lifeguard. So same process. Once we have our picture drawn, we want to label the sides. So with respect to this 18-degree angle, 8 would be the opposite side, and x would be the adjacent side. So I'm going to use tangent, because tangent is opposite over adjacent. I will have tangent of 18 degrees equals opposite over adjacent, so equals 8 over x. Now to solve for x, since x is in the denominator, I need to multiply both sides by x. Those will cancel out. I'll have x times the tangent of 18 degrees equals 8, and then to get x by itself, divide both sides by the tangent of 18, and these cancel, and this we can put into the calculator. 8 over the tangent of 18, 8 divided by the tangent of 18 degrees, and if we round to the nearest tenth, that will be 24.6. And we are given units of feet, so 24.6 feet. All right. Let's do one more example of an angle of depression. So on this one, we've got a pilot in a helicopter who spots a landing pad below. The angle of depression is 73 degrees. All right, so let's draw this picture here. So here's our right triangle. Helicopter's up here. Angle of depression, so that means that's this angle right here, is 73 degrees. But again, remember, that means that this angle would also be 73. These two angles would be alternate interiors, so they would be the same. Then we know that the horizontal distance to the landing pad is 1,200 feet. Horizontal is side to side, so that would be 1,200 right here. Remember, vertical is up and down, horizontal is side to side. We want to find the altitude of the helicopter. Altitude is just another word for height, so that would be this distance right here. All right. So label the sides that we have information on with respect to this angle. This would be the opposite side, and this would be the adjacent side. So yet again, we're going to use tangent. So my setup will be tangent of 73 degrees equals opposite over adjacent, so equals x over 1,200. To get x by itself, I will multiply both sides by 1,200. Those cancel out. And this then we can just put into the calculator. So 1,200 times the tangent of 73 degrees. $3,925.0 if we round to the nearest tenth. And this is in feet. All right. So remember, your assignment for today is to upload a picture of the notes that you just took to Schoology. There is an edge elastic up with some of these practice problems for tomorrow. And as always, send me any questions that you have.